we have to know the proparties of tangents. So in this lesson, we have to know what is the meaning of tangent and how we will find the proparties for this tangent, or it's talking about what. First of all, we have to explain what is the vocabulary which we can find it in this lesson. So we can say that a circle is, what's the meaning of a circle? So a circle is the set of all points in the plan that are equidistant from a given point. This given point is called radius. A segment whose endpoints are the center and any points on the circle is called radius. So when we found a line segment connect between the center of the circle and another point on the circle, so this one is called radius. And all radii in the circle have the same length. The diameter of a circle is a chord, because already we have two endpoints lies on the center, but the diameter is a chord go through the center of the circle. So the diameter is a chord, but we have a condition. This condition pass through the center of the circle. For any line, we have two different lines. So in the previous one, we were talking about a line segment, which it has a start and end point. It has two endpoints. So two endpoints, we have chord, we have radius, and we have diameter. But line, which means it will extend in both two sides. So we have two types. The first one is called secant, which is green one. This is secant. So secant is a line that intersects a circle at 2 points. So did you see this line? This line is called secant, intersects a circle at 2 points. And we have another one. This one is called tangent. Tangent, it's a line intersects a circle at only 1 point. This point is called point of tangency. So a secant is a line that intersects a circle in 2 points. A tangent is a line in the plan of circle that intersects a circle in exactly 1 point. This point is called point of tangency. So after we know the difference between lines and the line segments in the circle, we want to answer this question. Tell whether the line or segment is best described as a radius, chord, diameter, secant, or tangent of circle. Now, DC is DC. What is the best described to the line D?
Radius.
Radius. What is the best described to BD? BD.
Secant or a chord?
BD. It's a chord because it has 2 endpoints lies in the circle. BD. What about DE? Where's D? D.
Diameter.
Diameter. What about AE? AE?
Tangent.
Tangent. Thank you. Now, use the diagram to find the given length. First, we are looking for the radius of the circle D. So we will stand on the center, right? And we will count till we reach the circle. So how many units we can count from B till the X, or from the opposite side? Both it will give us the same. So we can count here. We have 1, 2, 3, right? So the radius here is 3. So what about the diameter now for the circle? For the diameter of the circle A. If I'm asking now about the diameter of circle A, it will be how many? Circle A, which its center is called A. We can count
4.
4, yes, because from the center we have 0, 1, 2, and the other side I have 0, 1, 2, right? So all the diameter, it will be equal 4. So by the same way, we can calculate the diameter of circle B. Now, we have different positions for the circles. Two circles can intersect in 2 points, or 1 point, or no points. Then, look at those 2 circles. Intersect at how many points? Those
2 points.
are 2 points. And those 2 intersect at
1 point.
1 point. 1 point is called the point of intersection, and this is 2 tangent circles. For this one, it's 2 tangent circles from interior. So we can call it, this is interior or touching internally. 2 circles touching internally. And those 2, it will be 2 circles touching externally. And both of them can intersect at only 1 point. Those 2, do we have any intersection?
No.
No. And the second case, do we have any intersection?
No.
No. We can call this one concentric because both of them have the same center. But those 2, it will be distant circles. Distant circles means that we have a distance from the
That
both
they are apart.
centers. Yes, they are far from each other. So we can say that those 2 is called distant circles. Now we will talk about a common tangent. A line, ray, or segment that is tangent to the 2 coplanar circles is called a common tangent, which it can pass through the 2 circles. Just touch the circle at only 1 point. So any line, any ray, any line segment touches circle at only 1 point, so we can call it common tangent. Understood? Now we want to know how many common tangents for the circles in front of us. For the first case, do you expect how many common tangents in A?
1.
This is what is the type for this for those 2 circles?
The 2-point intersection.
Two intersecting circles, right?
Yes.
Intersecting circles. Then we want to draw how many common tangents? You said how many?
I said 1, but I think it is wrong.
Yes, you said 1, but you think it's wrong. So we will check together. We can draw here 1 line from this side. So this is the first one. And we can draw another one from the other side like this. Right? So 2 intersecting circles, we can draw 2 common tangents. What about B, figure B? Do you expect how many common tangents?
2.
Let me draw and you will tell me. This
Okay.
one, it will pass through both. And this is 2. And we can draw 1 diagonal like this here. So this will be how many now?
3.
And then we can draw 1 from the other side like this. So we have how
4.
many? We have 4. Then in 2 distant circles, we have 4 common tangents. What about 2 circles touch externally? How many common tangents? So 1, 2, and 1 from the middle. So how many do we have?
3.
3. Then 2 intersecting circles, we have 2 common tangents. Distant circles, we have 4. Touch externally, we have how many?
3.
3. What about if they are touching internally? Do you expect how many common tangents?
1.
1. Very good. Now we have another part. In a plan, a line is tangent to the circle if and only if the line is perpendicular to a radius of the circle at its end point on the circle, which means line M is a tangent, QP is a radius. So once we have tangent and radius, so we are going to know that QP, it will be perpendicular on line M, and the angle between them should be equal 90 degrees. Then tangent intersect radius, then they form a right angle. In this question, in the diagram, AB is a radius of the circle. Is BC tangent to the circle? A. BC is a tangent to the circle or not? How we will know that BC is a tangent to the circle? We will use converse of Pythagorean theorem. Please be ready with your calculator. We will use converse of Pythagorean theorem. If we want to prove that BC is a tangent, then AC, it should be what? AC should be hypotenuse. So we want to prove that the square of the hypotenuse, it will be the sum of the squares of the other two sides, which means we want to prove now that AC to the power of 2 equal AB to the power of 2 plus what? AB to the power of 2 plus
BC power of 2.
to the power of 2. So don't forget, we have to put for ourselves a plan. Now, you want to prove that BC is a tangent, then you have to prove that AC squared equal AB squared plus BC squared. Now, where is AC? It was how many? AC was how many?
7.
67. Then please calculate 67 to the power of 2. It will be how many? Then we want to write AC to the power of 2 equal AB to the power of 2 plus BC to the power of 2. Now 67 to the power of 2, it will be equal, we want to prove, or we will not put the sign equal now and we will check. The other side I have how many? 25 to the power of 2 plus 60 to the power of 2, which means we selected the greatest side in your left hand and then the other two sides in the right hand. Could you please tell me 67 to the power of 2, it will be how many? 67 to the power of 2.
4,489.
How many?
4,489.
Then 67, 4,489. Okay. The other side. 25 to the power of 2, it will be 625. 60 to the power of 2, it will be
3,600.
3,600. Then add them together. 3,600 plus 625, it will be
4,225.
2,225. Okay. So I missed something. He put here, this is 67, and this one should be equal this one, right? So we're missing that this one is how many? 25. We calculated already, he put that this part is 67. He didn't mention a letter here. If he put a letter here, which means we are going to deal like this is 25 and this is 25, right? But in this question, he put 67 and he put 25 and he put 60. And he said in the question, is BC tangent? So in this part, did you find that the both sides were equal? 4,489 and 4,225. Those are not equal, which means it will be a tangent or not?
No, not tangent.
No, it's not a tangent. Okay, why? Because the square of the greatest side not equal the sum of the squares of the other two sides. What about if both sides were equal? So we can say that it will be a tangent. Okay, then to prove that the line is a tangent, then we will use 67 square, 25 square, 60 square, and then we will compare between them by this way. Understood?
Yes.
Let's move to the next part. In this question, in the diagram, S is the point of tangency. Find the radius of the circle. In this question, he divided the line into R and 36, right? And this one is TS and this one is SR. Already in this question, he said point of tangency, which means this one, it will be a tangent to the circle. Then we are looking for R. We will use Pythagorean theorem. Now, write the TR to the power of 2 equal what? TR to the power of 2 equal what?
48 power of 2 minus 36 power of 2.
Yes, so it will be TS to the power of 2 plus SR
No.
to the power of 2.
Miss it, will it be to TR to the power of 2 and SR to the power of 2, not TS?
No, TR to the power of 2, this is hypotenuse, and TS, right, to the power of 2, and SR to the power of 2.
Okay.
We will replace now. TR in this question, he mentioned that we have a distance R. Then it will be R plus what? Plus 36 all to the power of 2 equal R to the power of 2 plus 48 to the power of 2. Now we have to expand. We studied perfect square numbers. Then R times R, it will be how many? R to the power of 2 plus 36 times 36. It will be how many? Grade 9.
1,296.
Exactly 1,296. And then I will multiply all times 2. It will be 72R. So we said that this one is perfect square number and we want to expand it. So we will multiply R times itself, it will be R. 36 times 36, it will be 1,296. First times second times 2, it will be 72R. Now this one equal how many? Equal R square plus 48 to the power of 2, it will be 2,304. Now, this is equation, right? And we have in both two sides, we have R square and R square. So we can simplify now. I can cancel R square and R square because if you will transfer this one to the opposite side, you are going to make it 0. And then I will combine now 1,296 and 2,304 together. Then it will be, in this side I have 72R equal 2,304 minus 1,296, and we will divide by the end if I want to simplify. So I have 72R now equal how many? 2,304 minus
You want the first answer?
1,296. It will be 1,008.
1,008.
So what is the value of R?
R equal 14.
Yes. So we will divide both sides now by 72, which means the answer, it will be equal 1,008 divided by 72. So the answer, it will be equal 14. Right? So in case we have a question like this, he put a tangent. So we said that this angle should be 90 degrees, or we can say that TS perpendicular to SR, and he's looking for R. So this hypotenuse is consists of R plus 36. And this one is R and this one is 48. So we are going to make the converse, sorry, we are going to use the Pythagorean theorem, TR square, which represent the hypotenuse, equal TS square and SR square, and you will add them together. For the perfect square number, you will multiply R times itself, R times R, it will be R square. 36 times 36, it will be 1296, and then multiply all together, it will be 72R. And the other side, and then cancel R square with R square, and then continue to solve the equation. We found that the length of the radius equal 14. So this is how we can use a tangent with radius. As I said, once we have tangent and radius, so we have a right angle. And we will use Pythagorean theorem to find the length of the radius. This is the another part about tangent segments form a common external point or congruent. So we have SR and we have ST are tangent segments, then those two lines, they will be congruent. So once we have two tangents intersect at a point outside the circle, then they have the same length. In case we have a question like this, AD is a tangent, BD is a tangent, so we are looking for the value of x. Could you please tell me how we can find the value of x? We will solve it like an equation, right? So it will be both they will be equal. Then it will be 6x
minus 8
minus 8 equal
25.
25. Then
We will transfer the 8.
Exactly. So we have now 6x. It will be equal 25 plus 8. Then
33.
so 6x equal how many?
33.
33.
Yes.
Then we will divide both by 6.
6.
So the value of x, it will be how many?
5.5.
5 point what?
5.
5.5. Okay, then this is how we can solve equation with two tangents intersect from a point outside. Then two tangents intersect at a point outside, so we have AC should be equal, AD should be equal BD, and then we will solve the equation to find the unknown value. Okay, so this was our lesson today. Use proparties with use proparties of tangents with the circle.